Okay, hello everyone and welcome. I'm here, I'm alive, I'm still not feeling well, but I'm going to try and get through some materials for today. As you've probably already heard via the email, I am pre-recording this video for today just because I do not know if I'll actually be well enough to give class online, so I was just going to do it when I felt like I had the energy and post this video for you all to watch today. I understand that this is not the ideal way to start this class. I'm not having a good time either. My family is all sick. My wife was sick. My kids were sick. I'm still sick. We are having an absolutely miserable time over here. So I am very sorry that I'm not there on campus with you today. I really wish I could be. And I certainly hope that I'll be able to rejoin you all on campus soon. And thank you for your patience as my family works its way through this absolutely terrible illness. As far as today goes, I wanted to start off by bringing a couple of things to your attention before I hop into the course materials for today. First up, if you look on Canvas, I did finally post the video from class last week. I know I was not very quick in getting that posted because I was very, very sick, but I did get that video posted. Sorry for the delay on that. I will post videos from class every week, so you can find them usually listed as Module 1 review. So that's the material that we covered in class last week. Today's video will be posted as Module 2 review. And then I also posted a studio review video for Studio 1. So this is a video of me going through the studio problems that you were asked to complete in class and working through my own solutions for them. I generally also talk about the homework assignment a little bit during these studio review videos, so definitely take a look at them if you have any questions about the concepts that were covered on the studio. If you ever have to miss the studio for some reason, those videos are a good way for you to keep up with the class. Typically, I do like to record them, so I will record a brand new one every Friday, although this one I took a shortcut and posted the one from last semester since I just was not feeling up to it this week. So keep an eye out for those two videos will be posted every week. The module review video will be posted after lectures that shows this, what I'm talking about right now. And the studio review videos will generally be posted on Fridays that show me going through the studio solutions. So please keep an eye out for those. Those are some great resources. I always take good feedback about those videos and want to make sure you're aware that they're being posted and that they exist. For today, we're actually starting in on Module 2. So we're going to be covering choice and iteration. So I'm going to go through a bunch of the Module 2 exercises today. The Module 2 exercises are in the same repository as the Module 1 exercises, so there's really nothing you need to do ahead of time. You should already have all of these exercises loaded up in Eclipse and ready to go, so I'm going to go ahead and hop right in. Our first example is called test rating. And as you can see up here at the top, we start off with something we already know how to do. We're creating a Boolean variable, but just to kind of recap, since we're all still sort of new at this, right? When we are creating a variable or declaring a variable, the first thing we list is that variable's type. In this case, the type given is Boolean. We're going to see a lot of Booleans today, as a matter of fact. The next thing is going to be a name. So this variable is called isRating. And then finally, we've set a value to it. Recall that when you see a single equal sign in this class, we are generally taking the value on the right-hand side of the equal sign and putting it into the variable on the left-hand side of the equal sign. So this should create a Boolean variable for us and set it to be true. And now we've hit on one of the first new keywords of today, the if keyword. So if allows us to make decisions. It allows us to make choices. It allows us to selectively execute code. So basically, we have a choice. We might run this code or we might not. It depends on the result of the if statement. So the way that if statements work, obviously we start with the word if, followed by parentheses, and then inside of the parentheses must go a boolean statement. In this particular case, we've just got a single boolean variable, but it could be more complex than that, and we'll start to see some more complex boolean conditions as we go along. But for right now, we just have a single boolean variable. If the value of this boolean is true, then it will proceed inside of the curly brackets and do what's inside of the curly brackets. It will run these lines of code. If the boolean value is false, then it will skip these curly brackets and it will not run this code. It will not execute the code that is inside of those curly brackets. So you can easily verify this just by running this program a couple of times. You can see it's currently set to be true, so if I run it the first time, we'll see that it tells us to take an umbrella, right? So it actually did execute this. This variable was true. That said, all right, you need to do the things inside of the curly brackets, but if I switch this to be false, the next time I run this program, we'll see that it did not tell us to take an umbrella. It came across the if statement. It said, oh, this value is now false, so I'm going to just jump over all of this. I'm not going to do any of it, and I'll pick up at the bottom, right? So there might be more code after the if statement. You have to, can look afterwards and see if there's more work for you to do. But if you have a false value here, you can just skip over everything inside of those curly brackets and move on to whatever the next thing is on your list. So we don't see the notion for the umbrella included in this particular example. We can also do this with numbers. So I think it's actually more common to see if statements used with these kinds of comparisons. And we're actually going to take a little bit of a tangent here to start off today and talk about a particularly important topic, which is random numbers. So right up here at the top on line number 8, we can see a line of code and the comment that's given here says that it's generating a random number from -10 to +10. But I would like to discuss exactly how that's happening and more generally how you could generate any range of random numbers that you would like. So let's take a brief detour, talk about random numbers for a moment, and we'll return to our discussion of if statements. When talking about random numbers, the main way that we have to access them is through math.random. But math.random is going to give us a number between 0 and 1, where it could give us 0, but it will never give us 1. So the largest value it will ever give us is 0.9999 repeating, right? So how do we take something, between 0 and 1 and somehow turn it into a bigger number between -10 and +10 or -100, +100? We can generate random numbers in any range that we want. Well, let's think about, what this is doing. We're multiplying by 21. And that might seem like that number was just pulled out of thin air, but it actually wasn't. 21 is the range from -10 to +10. Remember that 0 is in there, right? So that's why it's 21 instead of 20. So this is the range. If I want to generate random numbers from a specific range, I need to know how big that range is, and I need to multiply by that range. So that's the first step, right? Excuse me. The second step is to recognize that since math.random starts from 0, if I wish for my random numbers to start at a different place, I'm going to need to adjust them. So here you can see that my random numbers, I want them to start from -10, which is why there is a -10 over here on the end. If you kind of work through this in your head, right? I always like to work through what's going to happen at both the low end of math.random and the high end of math.random. If I get 0 back, then 0 times 21 is 0, -10, that gets me -10. If math.random were to pick a very large number, like 0.999, then I would get something that is almost 21, right? -10, so that would get me something that is almost 11, correct? But it never will be 11. Almost, but not including 11. And then this last part out here, which I haven't mentioned as just yet. We talked about this last week. This is a cast. So math.random gives us values between 0 and 1. Those are doubles. If we specifically want integer values, then the way to take something from an integer, the way to take something from a double to an integer is to apply a cast to it, which is what has been done here. So that number that is almost 11, well, you can give it a value. It's 10.9827, right? If that's what you want to think that it is. When it's cast to an int, that has the effect of chopping the decimal off. It does not round, it chops the decimal off entirely. That would have the effect of giving us the 10, which is the upper bound that we are looking for. More generally, right, if I think of generating random numbers, in the range from low to high, right? So I'm trying to define this in the general sense. Generating random numbers in the range from low to high. So it's going to be math.random multiplied by the range, which is going to be, excuse me, sorry about that, which is going to be, it should be the upper bound plus the lower bound, and you may need to take the absolute value there as well to get the full range. But yes, multiplied by the range minus the lower end. This will do it. Multiply by the range, subtract the lower end. This will give you a double, so this will give you random values that can include decimals, right? If you wish to include, if you only want to have integers as your random values, then you have the option to include an additional integer cast out front, which leaves you with a statement that looks very much like what you see up here at the top. So I hope this makes sense. I know this is a topic that can be a little bit tricky. Be sure to ask a TA or come in and talk to me in office hours if this one's still a little bit confusing to you. But using this formula, we can generate random values in any range that we would like. All we have to do is substitute in the range of values that we want into this equation, and math.random will take it from there. Okay, back to the task at hand. We're going to assume that this code is doing what it's supposed to do and generating random values between -10 and +10. We are then going to check and see some information about this, right? Is it positive? We can ask that question with an if statement. So here, our boolean, you can see this isn't a boolean, right? Number is not a boolean, 0 clearly not a boolean, but we have a greater than sign in there. And that's what's going to get us our Boolean statement. Either this is greater than 0 or it's not. True or false. So if it looks at the randomly generated number and it says, oh, okay, yep, that's greater than 0, then it will do the stuff that is inside of these curly braces. If that number is not greater than 0, then it's just going to skip right over that and come down to the next if statement down here, where we're doing equality. This might look like a mistake, but it's not. When testing equality in code, we use 2 equals signs. So be careful. Using 1 equals sign, that's how we assign a value to a variable. That's how we say, take the number 0 and put it in the variable called number. But that's not what we're trying to do here. I'm trying to ask the question, is this number equal to 0? And so that is what this if statement is trying to accomplish. It's saying, all right, number equals 0. Either it is or it isn't. That statement is either true or false. If number is 0, then it's true, and if it's anything else, then it's false. So it will look at that value and evaluate it, determine whether it's a true or a false statement, and execute the code inside of the brackets accordingly. And so we can test this. We can run this a few times. It should generate some random numbers for us. The number is -9, which doesn't trip any of us, right? We're only going to get if statements if it's positive or 0. 10. 10 is positive. That's good. You got a 1 in 21 chance to get a 0, so it's not very good odds, but oh, okay, thanks. I needed that. Truly, that's some good luck right there. I appreciate it. But just to go back to my previous point about how to generate random numbers, let's say I did want to generate a different range here. Let's say I wanted to generate random numbers between the range of 5, not -5, +5 to 25, right? Well, let's do a different number. Let's do 50. From 5 up to 50. Okay? If I want to get values from 5 up to 50, the range between those two, I believe would actually need to be listed as not 45, but 46. Although I might be off on that. No, I think it might be. I'm gonna claim sick brain on the. No. That's not good. That's not an excuse. Yeah, it would be 46. It's always one more than you think it is due to the range, because we do wish to include both of these numbers as part of our range. So the range would be 46, and the offset that we do here at the end now would not be -10, but just simply +5. And with those simple tweaks, we now are generating random numbers between 5 up to 50. I can run this program and show you. There's 25. There's 45. Should never get one greater than 50 though. 13 is good, or less than 5 for that matter, right? Cool. Appears to be working. Yep. Alrighty. Next topic. Okay. So when we've looked at if statements so far, it's given us a way to conditionally execute something. Either we do this thing or we don't do this thing based on the result of the boolean that is given to the if statement. Sometimes it's there's more than one option for us to pick from. So it's not just we either do it or we don't, but I'm trying to choose between a fork in the road. I either want to go left or I want to go right, or something along those lines. And so in that case, we can use something called an else statement. I'm going to pull up the example called driver's test next. And the way that this one works, we've got our good friend Scanner here. That's good to see. It's going to ask us what our age is. And if our age is greater than 18, it's going to tell us that we can get a driver's license in most states. Yep. But then down here we have a statement called else. And so what else is going to do for us, if we are not greater than or equal to 18 in age, we'll skip this code, but we are then guaranteed to do whatever is in this else statement. So if I fail this condition, I'm just automatically going to come down here and do this one. You'll notice there's not even a boolean listed here. We don't need one. We're just saying, all right, you didn't do this one, but I'm going to make you do this one. Notice that it will never do both. It is not possible for both of these things to happen during the same trip through the program. It is not possible. It's going to check this value. It's going to evaluate it to be either true or false, and then make a choice as to which path to take. So we say that these outcomes are connected to each other, right? They're definitely connected to each other. The else statement allows us to have these two connected outcomes based on the same check, based on the same question that we are asking. So we can very quickly test this here. It's waiting for me to type in my age. I'm an old guy. I do have a driver's license, but if I type in a value that's less, it'll say, sorry, you need to be older. So this was false. It skipped over this, but since this else was here, it automatically goes ahead and does it. The fact that these two things are linked together, the fact that they're actually changed together, is very important. I don't want to underemphasize that fact. In fact, let's take a look at another example that will hopefully make that clear. Here we're asking, did you pass the midterm exam? And we're using the scanner to read in a boolean. That's interesting. We have to type in either true or false. But look at the way that this code is written down here. It's saying if you pass the exam, then good job studying. If, and then this exclamation point means not. So think about what that means. If passed exam is false, the not will make it true, and we will do the code that is in here. So these two conditions are sort of the opposite of each other. Do you see that? If pass exam is true, this code is going to get executed. If pass exam is false, then this code is going to get executed. But these two things are separated from each other. These are two distinctly separate if statements. And they don't have to be. There's actually been some extra work done here. I would actually say that this is not necessary, although let's run it first just to make sure. Did you pass the midterm exam? True. Good job studying. Did you pass the midterm exam? False. Study harder next time. That's a little mean in my opinion. But anyway, instead of writing this as two separate if statements, since these are related to each other, right? Since these are related to each other, I can connect them with an else statement instead. So the code that I have up here on the screen now is functionally equivalent to the code that was up here before, and I would argue more structurally sound, as it clearly relates that these two outcomes are related to each other. They are not. I think of an if statement as asking a question, and so when I see two if statements, that seems to me like you're asking two questions. But really, these are just two different possible outcomes to the same question. And the else statement is a more accurate reflection of that fact. And it should work exactly the same. So if I type, if I type in true, it'll tell me good job studying. And if I type in false, it'll tell me to study harder next time. Okay, so what if you have more than two possible options to take then, right? Sometimes there's not just a fork in the road that goes left and right. Sometimes there's a fork in the road that goes left, middle, right. Or, right, I've got three options that I can take instead of just two. Or maybe I have 100 different options, 100 different possible paths to choose from. Okay. We can handle that as well. That is also a thing that we're capable of dealing with in our code. Let's introduce one final little tweak to our if statements. What we're going to be looking at this time is this little combination here, else if. So we have our original if up here that is, again, asking a question. Is x less than 0? If it is, it'll do this stuff. If it's not, it'll skip it. And then here, because I see another if statement, I am in fact asking another question. Okay, x is not less than 0. If x is 0, then I'll do this stuff. And if it's not, then I'm going to skip down to the next part. And when you hit the else gets done automatically, no matter what. There's no condition here for us to check. So we don't need to check anything. We just say, oh, we hit the else. That means we're doing the else, right? However, notice that if it had been true on one of these two up above here, we never would have gotten to the else. it would have done this one first, perhaps, or this one first, perhaps, if it needed to. And just like we saw in the prior examples, there are three conditions here, right? Negative, 0, and positive. This if statement, the way that it is written, will only ever do one of these three options. It can never do more than one of these three options in a single pass. Let me show you what I mean by that. We can actually verify that by playing around with this code a little bit. X is currently set to 2, which is very much a positive value. So if we think about, I'm actually going to run the debugger. I love running the debugger. I think this is a great example to do it. I'm going to set a breakpoint here on line 7 and go into debug mode. Okay, so here we are in debug mode. I'm going to step over, and X has now been set to be 2, and we're going to start asking these questions, right? And we'll see that as it answers the questions, it'll skip over code that's false and do code that is true. So here we see, okay, is X less than 0? It is not. So when I click the button, it's going to skip over that whole chunk. You just saw it skip over that whole chunk. Now it's asking the question, all right, is X equal to 0? Still not. So it's going to skip over that whole chunk and wind up down here in the else statement, telling us that X is positive. There we go. Let's switch the value of X. We'll make it a negative value this time. And run it through the debugger again just to verify what happens. Here we are again, running through this code. X is negative 1. We can see that over here. So now when it asks if X is less than 0, that is going to be a true statement, which means I would expect it to go in here and do this stuff, which it does. But the very important thing to note is that it is not going to continue on here next. Once we have identified which of these conditions applies to us, we are done. We do not check the rest of them. So it is going to skip the whole rest of the if statement, right? There's our X is negative message. It did not come here to check to see if it was 0. It didn't need to. We again, using if, else means that these conditions are all chained together. We are telling the computer by structuring our code this way that you must pick one of these three things. You must pick one of these three things. And so finally, if we say X is 0, just for completeness sake, run through our debugger one final time. This first condition is going to be false, so we'll skip it. We haven't found which condition is true yet, so we're going to evaluate this next one, which is going to be true this time, actually. So we'll do this one. But since we have found our matching condition, we're not going to look at the else. We're done with this if statement, right? And so we skip it. I know this can be a little tricky, but the way that these if statements work, we evaluate these conditions until we find the one that matches, and then we stop. If we don't find any, then we'll do the else. And one final thing that I want to make clear is that the else is actually optional. You don't need it, right? So this is also valid code. This is okay code to write. I've removed one of the three conditions entirely, but the same rules still apply. If X is less than 0, it's going to do this, and it will skip this. If X is equal to 0, it will skip this and do this. But if this is false and this is false, because there is no else here, absolutely nothing will happen. It won't print anything. And that's okay. That's exactly what the computer is being told to do in this situation. All right. Let's walk through a similar example. This is actually a common mistake that I see students making all the time. Might run this one through the debugger as well, because it's a great example of how to use the debugger to help solve some problems. you can see that I'm trying to take a score and convert it into a letter grade. So a score of 93, I think most people would agree, should be an A. And you've got the other scores listed down here. But let's go ahead and run this code and see what we actually get back out. It's telling us that we get a D for a score of 93. And that's not good. That's not what we want. So let's see if we can figure out why that's happening with our good friend, the debugger here. I'm gonna set a breakpoint on line number 7 and launch us into the debugger. There it sets up our score variable. There it sets up a variable to contain the grade once we determine what it is. And now we're going to start asking the questions. We're going to start running through the if statements. If the score is greater than 90, then the grade should be an A. And I think we all agree that that's what the grade should be. And hopefully at this point we think that, oh, the code should stop. It shouldn't even bother checking the rest of these, right? Because we have found our answer. But if I keep pressing the button, you'll notice that it actually does continue on and continue to check the next one. So it is now about to ask the question, is score greater than 80? Which it is. It's a 93. So yes, the score is greater than 80. So what happened? I'm just using an if statement by itself here. An if statement by itself is a brand new question. It's a brand new thing as far as the computer is concerned. If we want the computer to understand that these are all conditions that are part of the same thing, they're all linked together, they're all connected, these need to be else if statements, not just regular if statements. You can see that it's going to ask each one of these, and the answer is going to be true every time because 93 is a high grade. So yes, it's greater than 70. Yes, it's greater than 60, right? And that's ultimately what happened to us. It got down here to this last one. If score is greater than 60, I get a D. Otherwise, I get an F. In fact, if you think about it, the way that this code is written right now, what I have highlighted is not doing anything for us functionally at all. The only two grades that I could ever get out of this code, as it is written, are D and F. Everything that happens above here does not matter, does not ultimately have an effect on our final outcome. Again, the way to fix that is to recognize that these conditions are all linked. They're all part of the same question that we are asking. And to indicate that in our code, we need to join these by using else if statements. Using if by itself is starting a brand new question. So that's something that you need to think about. Do I need to start a brand new question, or is this part of one that I'm already asking? That'll help you make the choice as to whether to do an if or an else if. Let's try this code again now. I'm going to stop it and restart it in debug mode. There's our score of 93 and our blank grade to start with. If score is greater than 90, give us an A, and then skip everything else. Oh, great. That's exactly what we wanted to see. I didn't need to check all of these other ones. I figured out what the grade is. It's an A. I don't need to check to see any of this other stuff, right? I know what my answer is. There it is. There's my A. All right. One more section about if statements. This next one is a very important one related to compound boolean statements. So I want to introduce you to a couple of compound operators. These are called logical operators, actually. So we've seen various types of operators already. I mean, the basic ones, the arithmetic ones, multiplication, division, addition, subtraction. Probably no surprise to see those, right? But we've also seen what I would call relational operators, or that is what they're called. They're called relational operators. Things like greater than, less than, equal to, not equal to. So those relational operators tell us how two values relate to one another. Is this one greater than this one? Is this one less than this one? They return a boolean value. Either it is greater than or it's not, right? It's either true or it's false. The other kind of operator that we're going to talk about today is called a logical operator. So there are many different logical operators, but the ones we're going to focus on are and, or, and not. And the one that we see here on this one is called and it's represented by two ampersands right there in the middle. And means that both the left side needs to be true and the right side needs to be true for the entire statement to be true. That is the only way that an and expression will be true. Now we're talking about booleans here, right? So I have to have a boolean thing here on the left. So this is either going to be true or false. I have to have a boolean thing here on the right. This is either going to be true or false. There's only 4 possible outcomes. And in fact, in the textbook, they list the truth tables for these, which I would actually like to recreate for you here, because I believe it's important for you to know these things. Where's my ampersand key? I don't know why I'm having a hard time finding it all. There it is. Okay. So the way that and works, is that it will be true if and only if x and y are true. If you think about the other combinations that we could have, one of them could be false. So either x could be false or y could be false. In that case, x and y is going to be false. And then perhaps in the most obvious case, if they're both false, it will still be false. This is what's called a truth table. If you're ever unsure what the result of an and operation is going to be, just figure out whether you've got a true or false on the left side, true or false on the right side, and you can use this table to show you the result. However, and gets its name from the fact that both x and y must both be true for and to tell us true as a result. So what does that mean for our little code exercise here? This is me being, 100% dad mode right now. If you have cleaned your room and you have done your homework, you can go out. But if one of these things is false, this whole expression will be false. So you cannot go out. You have to do both of these things, right? It's not one or the other. You have to do both of these things. So if you have cleaned your room and you have done your homework, you can go out. And you can tweak these variables up here to see the different outcomes. You can see right now, cleaned room is set to be true and did homework is set to be false. We're looking at this row on the truth table right now, right? If I run the program, it'll say, sorry, you can't go out. The only way it'll tell me that I can go out is if both of these things are true, giving us this line from the truth table. You can go out, right? If either one of these is false, one or both, however, the and expression will also be false. There is a similar one called or, which we can see in this example. Or is given by two vertical lines, or actually these are called pipes. If you're wondering where you can find them on your keyboard, they're typically right above the return key, the enter key on your keyboard. You'll see a vertical line for the that you can use for ors. And I'd like to construct a truth table for this one as well. it's the same as before. There's only 4 possible outcomes. So, right, they can both be true, in which case or will be true. One of them can be false, in which case actually or is still going to say true. Or they can both be false, in which case or will in fact tell us false is the result. So to kind of counter this with the way and works, or will give us true as long as x or y, as long as either one of them is true. If x is true or if y is true, x or y will be true. So if we think about how that applies to this particular example, if the place that I'm going is within walking distance, or I have a car available to me, then I can go out. Right? It has to be one of those two things. It has to be one of those two things. It doesn't have, I mean, it could be both. You can see that both is a possibility. Where I'm going is within walking distance and I have a car available to me. I can still go out in that situation, right? Only in the case when the place I'm going is not within walking distance and I don't have a car available am I not able to go out. So only in the case when both of these are false would I get false as a result of this or and be told that I can't go out. That is currently how it's set up here to be false, so let's go ahead and run that first. So both of them were set to be false. We got this line on the truth table. But let's say that I just want to go to the Shake Shack that's right down the street from me. That's walking distance. I could walk there. Well, I couldn't right now, but if I was feeling well enough, I could. And yeah. Now, since the place that I'm going is within walking distance, I'm able to go. But if I'm trying to make it all the way over to campus and my car is at the shop, then that's going to be a problem, right? Alrighty. That is going to do it for our conversation about if statements. We're going to switch to our next topic for today, which is loops. So if statements allow us to ask a question. They allow us to conditionally execute something. So I can make a choice as to whether I actually want to execute a piece of code or not based on whether the condition of the if statement is true or false. What loops are used for is for repetition. I wish to do the same thing many times in a row. It certainly would be possible for me to type out the instructions to that thing 100 times in a row, but I think you all would agree it would be very tedious to have to do that. So instead, we have a construct called loops that allow us to tell the computer to repeat a certain set of statements a certain number of times. So that's what we're going to take a loop at next. The good news is they feel somewhat similar to if statements in a way. They rely a lot on booleans, so we're going to keep talking about Boolean expressions and evaluation as we continue to talk about these loops. This is a while loop. So I see the word while there. That's an indication that I'm about to start a while loop. I see parentheses coming after the while loop, and inside the parentheses, just as I did before, I see a Boolean expression. I see something that's either going to be true or false. The big difference between an if statement and a while loop, however, is that a while loop will continuously evaluate this condition and keep doing whatever is inside of these brackets until whatever this is becomes false. So when we first start this loop, you can see I've initialized count, which is my loop variable. That's the variable that I'm using to keep track of how many times I've gone through this loop. I set it to 1. I evaluate this condition and it says 1 is less than 5. That is true. And because that is true, it will do what is inside of these brackets. But once it's done doing that stuff, it's going to come back here and it's going to ask this question again. Is count less than 5? Let's start the debugger and actually walk through this and see that in action. I think it's very important to understand how these loops work. Oh, that's my last program still from when I was talking about if statements. Let's switch it. Okay. I forgot to set. Did I forget to set? No. There we go. There we go. All right. Here I am on line number 8. I step and I see my loop variable count gets started out at 1. It's going to ask the question, is count less than or equal to 5? It is. So it's going to do the stuff that is inside of these brackets. It'll print out the value of count, and then it's going to increase count by 1. So count is now going to be 2. Notice where we are though. We did not go past the end of the loop. We went back up to the top. And now we're going to ask the question again. Count is now 2. Is 2 less than 5? Yes, it is. So we're going to do the stuff inside the brackets. We're going to increase count by 1. And we're going to go back up to the top. And we're going to ask the question again. Is count less than 5? Yes. Yes, it is. You can probably kind of see where this is going. So I'm going to fast forward a little bit through here till we get to the interesting part. Count is equal to 5. 5 is equal to 5, so we're still not quite there yet. All right. Count is now equal to 6. 6 is not less than or equal to 5. That is a false statement. We have finally made this be false, and we are going to leave the loop. So you can see that this print line statement and this count plus plus statement got repeated many times based on how we structured this loop. In fact, this is a very common way of structuring our loops. Initializing our loop variable outside, specifying our condition, and then incrementing the loop variable within the body of the loop. These are the 3 components that you will see as part of any loop that you come across. It's important that you have all of these 3 parts, in fact, because if you accidentally forget one, it can lead to some interesting situations. For example, if I take this guy off, think about what effect that's going to have. Count starts at 1. That is less than 5, so I'll print it out. But I took out the part that makes it go up. So count is always going to be 1. It will never be anything other than 1. 1 is always going to be less than 5, even for extremely small values of 5. So this loop is never going to find a false statement. This is never going to evaluate to be false. If I run this, you can see down here at the bottom of my screen that my computer is cranking out 1s as fast as it possibly can. This is the loop in action. It's running right now. This is what I told it to do. This is usually not what we want. This is an infinite loop. This is a situation where we've hit a loop that we will never get out of. This is typically not what we are looking to do in our code, which is why it's very important to make sure when you're writing these loops yourselves that you've got all 3 of these parts. And more specifically, it is 100% necessary to make sure that this condition will eventually be false. Will eventually be false. So yeah, just be careful. But I also want to make it clear that there are lots of ways that you can tweak these loops. Lots and lots and lots and lots of ways that you can tweak these loops. So, could I start, what happens, for example, if I start count at 10? Think about that for a second. I start count at 10, count less than or equal to 5. That's false right away, so this loop's not going to run at all. That can happen sometimes. If the conditions for the loop aren't appropriate, it's possible for the loop to get skipped entirely, right? And nothing gets printed out. Okay, well, let me put it back to 1. And maybe instead of saying count plus plus, I'll say, count is equal to count plus 2. I'm going to count it by 2's instead of by 1's. Is that okay? Yeah, absolutely, but it's going to have an effect on our loop, right? Instead of getting 1, 2, 3, 4, 5, I get 1, 3, 5. Well, okay, I hope you can see that by tweaking these different values, I can now write loops to generate any sequence of numbers that I could possibly conceive of, counting upwards, counting downwards. The sky's the limit, and it's up to you as the programmer to make those determinations and write your loops accordingly. Now, there's another style of for loop that exists called a for loop. And this is actually the exact same example. This example is 100% functionally equivalent to the while loop example that we were looking at. It does exactly the same thing. I'm going to run it through the debugger though and show you how it works, just so that we can see that it does in fact do the same thing. This time the big difference is that all that stuff that I showed you before appears to have been crammed into one big line. So it took some of the pieces from our while loop and shoved them all together. That count plus plus is up here. There's my count less than or equal to 5, and my int count equals 1 is here too. So I took all three of those components and just put them all in one place. Let's think about what that means. This is the initialization of my loop variable. This happens once at the very beginning of the loop. So this line is just going to happen one time at the very beginning of the loop. This condition will be evaluated at the beginning of the loop every time, just like we saw for the while loop. This will be executed at the end of the loop every time. So if we run through this code, we can see that count does start off at 1. That's my initialization doing that. It did also evaluate that 1 was less than 5. If I had made this 10, this loop would not have run. 10 is not less than 5. Okay, so it's going to go ahead and print out that 1, and then it will go ahead and increment count using this. That's the next step that it's going to take, and make the comparison. It did both of those steps at the same time. It incremented count to 2, and then ran this comparison. Is 2 less than or equal to 5? It is, so it's going to run the code inside of the loop again. All right, it's going to do that same process. Count plus plus, is it less than 5? 3 is in fact less than 5. 4 is less than 5. 5 is equal to 5, so that still counts. And then now finally, count is going to go up to 6. 6 is going to fail this condition, and just like we saw with the while loop, it's just going to kick us out and drop us off at the end of the loop. So those are the two different ways that you can write loops in Java, both a for loop and a while loop. A lot of times students will ask me questions like, why do we have two different kinds of loops? Is there a better time to use one loop than the other? Do I have to use a certain kind of loop? And the answer to all of these questions is, well, it kind of depends. But there are certain situations that apply better to while loops than to for loops. For loops are really good for situations when we know how many repetitions we would like to have. If I know that I need exactly 10 repetitions, if I know that I need exactly 100 repetitions, or even if I don't know the exact number, even if I just know that I need X repetitions, for loops are very good for clear, straightforward numbers of repetitions. You can also do that with while loops. I showed you how that was possible. However, while loops are typically considered better for when I don't know how often the repetition is going to need to happen. And the big place where you're going to see that coming up, here's a big fat hint for assignment 2 that I'm about to drop. User input. Let's say I'm asking a user to type in a number, but they can't just give me any number, right? They have to give me a number within a certain range that I'm looking for, or else what I'm trying to do isn't going to work. So if I'm saying give me a number between 1 and 10, and the user types in 15, then I need a way to say, no, that's not the right number. Please type in a number. But we don't know how many times it's going to take the person sitting at the computer to type in the proper value. We don't know how many times it's going to take them to type in a value between 1 and 10. They may never do it, right? They may give up and walk away. That's a possibility too. But a while loop is the best tool for that situation by far. Not an if statement, not a for loop. Whenever I'm reading in user input, looking for specific values, while loops are the right tool for the job. And you're absolutely going to have to use them for that purpose coming up on assignment number 2. So keep that in mind. In general, though, I would say that most students, in my experience, prefer for loops. They would actually prefer to write for loops over while loops when possible. And that's fine. I don't have a problem with that. I would say for most of the situations in this class, either a for loop or a while loop will work. And in that case, it is up to you. It is up to your personal preference, whether you write it out as a for loop or a while loop. I don't care. I want you to kind of develop your own comfort, your own feeling for the language. That's part of programming, the fun part, in my opinion. All that being said, it's definitely possible to convert back and forth from while loops into for loops into while loops. And so I'd like to walk you through an example of doing just that. Here's an example of a while loop. I would like to turn this into a for loop that does the exact same thing. So let's run this code and make sure we understand what it's doing first before we try to write the corresponding for loop. It looks like, okay, so my loop variable starting at 5, here's count less than or equal to 10, and I'm getting 5, 6, 7, 8, 9, 10. There we go, that looks good. I need to convert this into a for loop, which means recognizing those 3 parts and consolidating them all down into the same place. Fortunately, we have those 3 parts already given to us, so we can kind of borrow them from up above. The first part of a for loop, remember, is the loop variable initialization. And so for a while loop, that typically happens outside of the while loop. Happens right here. I'm just going to go ahead and grab that and put it there. I'm going to change the name of it so that it's not the same as the one up here, just to avoid those issues. The next part of a for loop is the condition. That's going to be, this guy right here. That's the part that was the same. Let me switch this so that it says C. And the last part of the for loop was the increment or the update. I think update is actually a better word for this process, which goes on the end here. Typically, that'll be found inside of the body of the while loop. So all I did was grab those 3 pieces of the while loop, put them in the appropriate corresponding place as part of my for loop. The only thing that's left remaining is to make it do the work, make it do the repetitive work, which is just printing out the count value. I'll go ahead and run this, and hopefully we'll see. Oh, I see what I did wrong. I see what I did wrong. I forgot to switch all the variables. You could write infinite for loops too. That's what you just witnessed. You just witnessed me completely 100% accidentally writing an infinite for loop. And I know I was in a big hurry to fix it, but I actually kind of wish that I wasn't, because we make these mistakes. Professional programmers make these mistakes. These are not mistakes you should feel bad about making. These are mistakes that everybody makes all the time. The goal in this class is not to avoid mistakes. The goal in this class is to embrace the fact that mistakes are going to happen and have the resilience and determination to fix them when we detect that they have happened and need to be fixed. That's really what programming is about. If you come into this class expecting to get to the point where you're writing perfect code the first time, you're going to be sorely disappointed. I do not write perfect code the first time. I do not write perfect code the second time. I would argue that there's no such thing as perfect code even. It takes a long time to get code functional. Mistakes are made often along the way, and it's our job as programmers to recognize those mistakes and fix them. Yep. So now that I have fixed that mistake, hopefully we'll see this for loop operating properly. There we go. Much better. Much better. I want to make it clear though that there's actually even more than one way you could have written this for loop. I could have tweaked this slightly. This is also equivalent. This is also, I would say, functionally equivalent. I took the equal sign off, but I increased this to 11. So 10 will still count, right? 10 is less than 11, but 11 is not less than 11. It's equal to 11. So this for loop is also actually 100% functionally equivalent to the while loop that comes above it. That's going to be a recurring theme you're going to see in this class. There's always going to be more than one way excuse me, to approach the same problem. And in large part, it's going to come up to your own personal preferences as to how you will ultimately decide to approach it. The last thing that I want to show you for today is going to step it up a notch. So the same thing is actually true for if statements as well, but we can put loops inside of loops. So I can put a loop inside of a loop. I can put an if statement inside of an if statement. And when that happens, these are called nested if statements or nested loops. So what I'm looking at now is an example of a nested for loop. And these, and we'll be seeing these a lot, especially, we'll see them again actually next week, as a matter of fact, when we have our discussion about arrays. And so let's talk about how this is going to work, right? Since this loop is inside of a loop, what that means is that this loop is going to be repeated this many times. So however many repetitions this loop has, that's going to be repeated this many times. So we can actually kind of look at this and try to decipher it before we run it. I can look at this first one and it seems like it's going to run 1, 2, 3 times. So row is going to go 1, 2, 3. Once it hits 4, this loop's going to be over. So this loop's going to run 3 times. Column is going to go from 1 to 5. 1, 2, 3, 4, 5. Right? But remember, this loop's going to be repeated 3 times. So those 5 repetitions are going to be repeated 3 times, which means that this statement right here is going to run 15 times in total. But be careful, this statement, notice this is outside of this for loop, right? But still inside of the first one. It's still inside of that first bracket. So this one's just going to run 3 times. This one will run 15 times, or the number of this iterations multiplied by the number of iterations here. Let's run through this in the debugger and see exactly how this is working so you can understand. I'm going to stop that one and switch down to my nested loops here. Okay, so when we first start off, I set my row to be 1. There it is. And I'm about to hop right into the second loop. Okay, I set my column variable to be 1. And now I'm going to run through this loop 5 times, just as I would expect. 2. And you see this, the stars appearing at the bottom? Because I'm using print and not println, they're all appearing on the same row, correct? They're all appearing on the same row down here. So there's 4, and there's 5. Now that that loop is finished, the next line that I would expect to go to is line 14. So I did the first 5 repetitions here. I'm now going to move down to the next line, and I have finished the first iteration of this loop. But I still have 2 more to go. Row is 1. It's about to go up to 2, and I'm about to do this loop again. So I did 5 trips through this loop already. I'm about to do 5 more, but this time row is equal to 2. Row is equal to 2 instead of 1. And I think that's important. I think that's very, very important to understand that the outer loop is somewhat controlling this inner loop, right? Controlling where I'm at within this inner loop. So here comes 5 more trips through my inner loop on row number 2. I'll do my print line. That moves me down to the next row. Finally, I hit row number 3. Gonna take 5 more trips through this one. And since that should be my last row on my outer loop, the program is now finished. Okay? So when you see loops within a loop, they're really just executing the same way. I know it seems more complicated because of the structure of having repetition inside of repetition, but the loops themselves are not operating any differently at all. So you can still work through them step by step, line by line, one step at a time. Another way I think to approach these is to consider what the values of the loop variables are going to be. So if you're trying to keep track of how this loop runs, let's keep track of what the loop variables are going to be over time. I'm going to come down here. I'm going to put in row and column, right? And the way that this loop runs over time, row starts at 1, and then column also starts at 1, but then the row stays at 1 while column counts up. I can run this through the debugger again to, in fact, verify that fact with you. It is not until we get through those 5 repetitions that the row value is going to increase and go up to 2. And so at that point in time, we're going to restart our inner loop, which is going to count the column variable from 1 through 5 again. Oops. And then finally, the last pass through the loop, row will have a value of 3. Okay, so this is what my loop variables, this is the order that they will change over the course of this program. Notice that it kind of looks like this outer loop is iterating more slowly than the inner loop is. I mean, however you want to think about it, whatever makes the most sense in your brain is what matters. But yeah. Definitely run this one through the debugger a few times if you have to. Make sure that it makes sense to you because you will be seeing it again. I'm going to run it through the debugger for you one more time just to show you that it does in fact follow this trajectory with the row and column variables. Oops. You can see there's row 1, there's column 1, 2, 3, 4, 5. Row goes up to 2. Column goes 1, 2, 3, 4, 5. Row goes up to 3. Column goes 1, 2, 3, 4, 5. And then we're done. This is a very common way of doing things in a rectangular way. So the words row and column here were not chosen here on accident. Using loops in this way is very often used whenever we're dealing with stuff on a grid or over two-dimensional space, which is something we actually are going to be doing here before too long. That's why we're introducing this concept to you now. I again also want to reiterate that if statements can also be nested. So if I come back up to one of the earlier examples, right? If it is raining, I can make another Boolean variable here. Is storming. So maybe if it's raining, I'll take an umbrella and go. But if it's storming, I'm not going to. Right? I'm not going to risk getting struck by a bolt of lightning. So if it's raining, but not if it's, wait, hang on a second. Let me think about that. Just do something like this. I don't know. This is not the best example, but I'm just trying to show you a quick example of how it is entirely possible to put an if statement with inside of another if statement. So it'll ask this question first, and then it'll ask this question afterwards. Okay, I believe that wraps it up for me for today. I am gonna go take a big old nap after I get this video posted to all of you. Once again, I'm very sorry that I could not be there today to present this class to you in person. I very much hope that I will be back in class later this week. I'm genuinely hoping to come to studios this week, and very much hope to be back at the regular lecture next Monday. Once again, thank you so much for your patience as I struggle through this illness, and I hope you all are taking care of yourselves out there. If any of you ever find yourselves in a situation where you're struggling for an extended period of time, please don't worry about this class. Your health is far more important. Take care of yourself first, and when you're feeling better, come talk to me, and we'll figure it out. Your physical and mental health are both far more important than anything that will ever happen in this course. So just want to make that clear. All right, I'm out. Have a good rest of your day.